All right, this is journal page 378, section 16.3. And we're working with powers again here. Number 1, 7 to the 6th power over 7 to the 5th power. Well, I've got 6 7s on top and 5 7s on bottom. When I cancel these out, remember it's just a subtraction of the exponents. I'm left with 7 to the 1st power over 1, or just 7. Number 2, negative 21 to the 15th power over negative 21 to the 9th power. Again, a subtraction problem, and I'm left with negative 21 in parentheses to the 6th power. Number 3, 3.9 to the 20th over 3.9 to the 10th equals, subtract the exponents, 3.9 to the 10th. And they have this 3.9 in parentheses, so I'll keep it in parentheses, even though those aren't really needed. Number 4, t to the 7th over t to the 3rd is t to the 4th. Subtracting the exponents again. Number 5, 8 to the 7th power times 8 to the 4th power over 8 to the 9th power. Well, we need to simplify what's on top here because actually this fraction bar is a grouping symbol. And remember, parentheses comes first, or grouping symbols come first. So this becomes 8 to the 7th times 8 to the 4th. Well, I have 7 8s here, and I have 4 8s here. So when I have them all together, I've got 8 to the 11th power over 8 to the 9th power. Now I can do this where I subtract my exponents, and I'm left with 8 squared, or 8 to the 2nd power. Number 6, similar, negative 1.1 in parentheses to the 13th times negative 1.1 in parentheses to the 12th over negative 1.1 in parentheses to the 10th times negative 1.1 in parentheses to the 1st. Well, on top, I'm going to have negative 1.1 in parentheses to the 25th power, adding those exponents. And on the bottom, negative 1.1 to the 10th and a negative 1.1 to the 1st is a negative 1.1 to the 11th. Now I can subtract those, and I'll be left with, and I'm going to put it down here, negative 1.1 in parentheses to the 14th power. Number, I'll put an equal so I know that where that came from. Number 7. Simplify the expression, so I have k times 3 to the 9th over 3 to the 5th. Well, on this one, I can't simplify anything on top here, but I can work with these exponents. 3 to the 9th over 3 to the 5th leaves me with k times 3 to the 4th. Well, we can simplify that a little more. This is 3 times 3 times 3 times 3, which is the same as 9 times 9, which is 81. So, 81k. Number 8, x to the 4th times y to the 10th times 2 to the 11th over y to the 8th times 2 to the 7th. Well, I can't simplify anything with my x's here, but my y's cancel out, and my 2's can cancel out some. So that'll leave me with, I'm going to move it down here, x to the 4th still on top. Y to the 10th over y to the 8th leaves me with y squared on top. 2 to the 11th over 2 to the 7th leaves me with 2 to the 4th on top. Well, 2 times 2 times 2 times 2 is 16. So I really have 16x to the 4th y squared. 9, I'm actually going to do number 9 up here. And it says the radius of a basketball is about 3.6 times greater than the radius of a tennis ball. How many times greater is the volume of a basketball than the volume of a tennis ball? Well, the only change in these two is that this is 3.6 times greater. The radius is. So the new volume would be 4/3 pi, and then it's 3.6 r, 3.6 times radius, but that has to be cubed. Okay? So the only difference is, for these two, for the volumes, is that 3.6, but remember that cubed applies to each thing in parentheses, so it's going to be 3.6 cubed. That's the only difference between these two volumes. The 4/3 would cancel on each side, the pi would cancel on each side, even the radius would cancel on each side. It's that 3.6 to the third power that is the difference. So what we have to do is cube 3.6. And 3.6 times 3.6 times 3.6 is obviously 46.656. So it's going to be 46.656 times greater, the volume is. Awesome. Well, if you have any questions, make sure you ask in class. Have a wonderful weekend.